Okay, welcome to Accelerated Math Operations on Complex Numbers. Don't get too concerned, it's not that complex, but a little bit. What they really mean by complex numbers is this A plus BI format where this is the real component and this is the imaginary. And when it comes to imaginary numbers, we have to basically treat this I a lot like a variable. And we'll see what that means in just a minute. Okay, and the I, if you remember from the previous one that we worked on, anytime you see a negative under the square root, you can just automatically pull that negative out, put an I on the outside, and then continue with your radical simplification. Square root of 6, you can't simplify that any. If I didn't know that, I could have gone to my calculator and done second square root of 6 and hit enter, and it's almost like it's making fun of me. Square root of 6 is the square root of 6. I mean, I can do the toggle to get the decimal, but that's not the point here. We're trying to stay with this whole square root thing. I did want you to notice that if you did the second square root of negative 6 and left that negative in there, it gives you a domain error, and that's because a calculator can't get the square root of a negative number, because the square root is defined as what number times itself gives you this number. Well, there's no negative number that you can get the square root of, because anything negative times negative would make it a positive, so that's where we're running into a little bit of a problem. So we put the calculator away, and over here, the square root of negative 10, well, I'm going to put that I on the outside. Now I know I've got the square root of 10. I'm multiplying these. Now here's where, okay, we've got the two things on the outside, I times I. I said treat it like a variable. All right, so I times I is I squared, not 2I, but I squared. And we learned in an I call it in my class an IFAX chart, I to the first is just equal to the square root of negative 1, or we just call it I to the second is, well, if you did square root of negative 1 times the square root of negative 1, it comes out, square root of anything times itself is going to give you that number without the square root. So I squared is equal to negative 1. And then we had some other things. I to the third came out with negative I, and I to the fourth came out to positive 1. But this is the one we're concerned about right now. All right, that I squared is the same thing as negative 1. So when we see an I squared, we're going to replace it with negative 1. Not the square root of negative 1, but just negative 1. So that got done with. Now we still have this square root of 6 and the square root of 10. I can combine those as the square root of 60, and then I can simplify that. I don't, if, or you can just grab your calculator. Let me get rid of this error, clear that error. Second square root and 60, and I get 2 on the square root of 15. I could have done that by hand too. 2 on the square root of 15, I could have said, oh, that's 4 times 15, and the square root of 4 is 2, so it's 2 on the square root of 15. So now I'm kind of going back to this. I had this negative 1 out here, and it's going to get multiplied with what I got right there, so it's negative 2 on the square root of 15. That's my answer, negative 2 on the square root of 15. So the I came out because it got squared and replaced with a negative 1, and then recombined or being multiplied back by what we had left on the other side. Okay, maybe it is a little complex. Whew. All right, let's go on to the next one. Maybe it'll start making a little more sense. All right, if I had something like x plus 3 times x plus 4, most of you wouldn't hesitate at using FOIL, first, outer, inner, and last, to do that. Well, you know what? And then you would combine your like terms, x squared plus 7x plus 12. The concept is almost exactly the same. It's where we're going to start, but then we're going to do a little substitution with I squared, just like we did in the last one. So let's do first. 3 times 3 is 9. Outer. 3 times negative 2, I said treat it like a variable. Negative 6i. Inner. Negative 18i. Last, negative times negative, that's plus 12i squared. I said treat it like a variable. Combine your like terms. 9 minus 24i, just like 6i and 18. I'm sorry, 6x and 18x would have been 24x, so this is negative 24i plus 12i squared. Now here's where it's just a little bit different. Just a minute ago we had defined I squared as being equal to -1. So that's what I call an I fact. If you know that, then you can use that to your advantage here. We're just going to replace I squared with -1. So now we have 9 minus 24I plus 12 times -1. When I multiply something times -1, that's just changing the sign of it. So it's 9 minus 24I minus 12. Now I'm going to combine my like terms. See, the I squared went away. 9 and -12, that's -3 minus 24I. I'm keeping it in this A plus BI format because that's the way they're going to want to see it. -3 minus 24I. There's your answer. Woo! All right. Some of you use FOIL. Some people use a generic rectangle. I don't want to get too crazy into it, but if you like this method, then it works the same. It's 9 and -18I, -6I, and plus 12I squared. You're going to combine your like terms. They're always in the diagonal, and you're going to do a little substitution there. You're going to end up with the same answer. All right, moving right along. Perform the indicated operation and write the result in standard form. When they say standard form, they're saying A plus BI. That's all they're talking about. All right, this one, whew, it almost looks like it's already there. But did you notice this? Some people, not you, but some people try to take that square and apply it to both things in here. Well, that's not what it's saying. When they said -6 plus 7I squared, they meant to multiply it times itself. Now, doesn't this look a lot like that problem we just saw, where you're going to use FOIL? So first, that's positive 36. Two negatives multiplied give a positive. Outer, -42I. Inner, another -42I. Notice they're both negative, so they're not canceling each other out. And then the last, let's see, 49I squared. All right, treat them like variables. Combine your like terms. 36 minus 82I plus 49I squared. I'm going to use that little substitution I learned a minute ago. I squared is equal to -1. I'm going to use that I fact. Put it right in here. So I've got 36 minus 82I plus 49 times -1. That -1 is effectively going to change the sign of this. So I've got 36 minus 82I minus 49. I combine my like terms. That's a positive 36 and a negative 49. That ends up at -13 minus 2I. That should be our answer. -13 minus, whoa, you caught that a long time ago, didn't you? You caught it. You didn't say anything. You should be ashamed of yourself. That was an 84. That's an 84. Thank goodness for multiple choice, huh? Now what? All right, I think I've got one more. I do. All right, there's the bell. You still can't go home. All right, so on this one, let's see. We're going to have a little distributive property here and a little bit of distributive property here. Let's see how this works. -I times -I. All right, so let me rewrite it here. -I times -I minus 7 plus 8 times 8 minus 4I. I'm going to do a little distributive property. -I times -I is I squared. Negative times negative is positive. -I times -7 is positive 7I. Got to really watch out on that distributive property. Plus, okay, 8 times that and 8 times that. 8 times 8 is 64. And 8 times -4I is -32I. You see how we're treating them like variables. Now, anything you see we can do? I'm going to listen. What are you saying? What are you saying? Combine my like terms. That's one thing to do. And someone else out there said, hey, I squared is equal to -1. They remembered that I fact. So we got several things we can do here. Let's go ahead and combine our like terms. All right, Colton, go to the front. All right. And there's tennis practice. Woo! All right. I need to tell them to stop running these announcements while I'm doing this. All right, 7I minus 32I. That is -25I. And then we've got, we're going to replace this I squared with negative 1. So now we're combining negative 1 and positive 64. That nets out to a positive 63. That's like 64 minus 1. That should be our answer. 63 minus 25i. There it is. All right. Excuse all the interruptions. I believe that was it. Yes, it was. All right. Have a good day.